Hello everyone, welcome to my channel and my class also. Now I am going to discuss resolution of vectors in a space or 3D. So in the previous classes we have done many problems based on the resolution of vector in a plane only, plane or 2D. Okay, we can understand the diagrams when the diagrams are drawn on the boards. Okay, that is only 2D. So what about the 3D? 3D nothing but in the space. Okay, now when our board is flying in the air, it is possess three dimensions or three directions: x-axis, y-axis, and z-axis. Okay, let us consider a point in the space. How can we represent the point? How can we locate that point? How can we specify that point? Okay, that we are going to discuss in this class. Okay, please listen to me. I am taking x-axis, this is x-axis, and this is y-axis, and this is z-axis. Okay, along x-axis I cap vector, that is unit vector, j cap unit vectors, and k cap unit vectors are taken respect to axes. Now I am going to find the position of this point A. How can we find this position of the point A? By drawing a position vector. Yes, by drawing a position vector. Okay, and this position vector divides into three components: 1, 2, and this is 3. Okay, so let us component x-axis, and along x-axis ax, along y-axis that is ay, along z-axis that is az. Now we can also draw the diagram angles. This is the angle between position vector to x-axis, that is alpha, in between beta, and this is gamma. Okay, na? So these alpha, beta, gamma are the angles, okay, na, by which we can measure the direction of the position vector, or we can specify the position vector. Okay, now here we are going to find the first point is what is the magnitude of the position vector, and second one directional cosines. Okay, directional cosines and magnitude of the position vector. These two things we are going to find in this topic. Okay, first one, what is the magnitude of position vector? Position vector. Do you know? And this is a cuboid. So how can we find that? Like this, we can simply draw. Yes, this is a cuboid. Cuboid consisting of three directions: length, width, and height. In the same way, space also possesses or consists of three directions. So what is the magnitude of the position vector? Let's find that. So we know that position vector, that is a bar, is equals to component and orthogonal vector or unit vectors, that is ax I cap plus ay j cap plus az k cap. This is the formula of the position vector or representation of the position vector along three axes. And what is the magnitude? If you take only magnitude, that is a, or we can also take it as mod a bar, and this is a equal to what? Square root of ax square plus ay square plus az square. This is the magnitude of the position vector, and so from this we can write it as square root is coming this side, that is a square ax square plus ay square plus az z square, az square. So this also let us assume as equation 1. So why we have taken like this means, so we are going to use this equation 1 in the next calculation. So second point is what already we have done, point 1, that is magnitude of the position vector. What is the directional cosines? Directional cosines. Cosine nothing but cos. Okay. So how can we find the directional cosines? Yes, there is a angle. Okay, alpha, beta, gamma angles are there. So this is triangle and this is triangle and also this is a triangle. So first let us find out cos alpha. Cos alpha is equal to what? If it is angle opposite, this is opposite side, this is adjacent side, this is hypotenuse. Okay, that is adjacent by hypotenuse. Equation 2 let us. And cos beta. Okay, I am writing cos value for this angle, that is cos beta, then adjacent by hypotenuse. This is opposite. Adjacent, that is ay by a, equation 2. And cos gamma, that is similarly az by a, equation 3. Okay, equation 3. Next, so I am going to add this 2, 3 and 4. Equation 2, 3 and 4. That is squaring up, sum of squaring of the equation 2, 3, 4. Or otherwise we can define like this. The sum of squares of the directional cosines gives 1 or unity. Okay, the sum of the squares of the directional cosine equal to 1. That we can simply write it as, therefore cos square alpha plus cos square beta plus cos square gamma is equals to right side, that is ax square by a square plus ay square by a square plus az square by a square. Yes, and this is ax square plus ay square plus az square. In the denominator, that is same, that is a square. Now what is this value? This value is a square. Equation 1 from equation 1. That is a square by a square gets equal to 1. Yes, that is cos square alpha plus cos square beta plus cos square gamma is equals to 1. This is very